We will learn how to evaluate LLM outputs with G-Evals. I will also explain my opinion on why you should not use number scores when evaluating LLMs, and I will give you an alternative that I use in my daily job and I think it works a lot better as AI researcher. So let's say you want to evaluate if this email is written in a friendly tone. I think you should not use number scores for that, and you should use a different strategy that I will explain. So I am AI researcher and engineer at beam.ai, where I use AI to automate business processes. So here are examples of the things I do. There are some issues with the previous ways of measuring it. For example, Blue and Rogue. If you are evaluating some text, you need reference text. And then what they do is just compare how many of these words are contained in these words, in this like reference text. Now that's a problem, because if we are creating some like new poem, we don't have like already created poem to compare how similar, like how many words are contained there. Now, if you are using GPT-4 or another LLM to evaluate the output, that provides more flexibility and that works better. However, there are some issues. There is a lower correlation between GPT-4 and humans, so it's not too high human evaluators. And also LLM evaluators tend to be biased towards scoring LLM generated text higher for some reason. In this paper, the authors will introduce G-EVAL, where they use chain of thought and probabilities of output tokens to create better LLM evaluator. Their results are that this method outperforms other methods by a high margin when it comes to correlation with human evaluators. They will also explore why LLM-based evaluators are biased towards rating LLM-generated texts higher. Some of their findings are that LLM-based metrics are sensitive to the input structure and prompt, and chain of thought can help provide more context and guidance. Since they are also using probabilities of generated tokens to create score, you can get a lot more continuous score as opposed to having a discrete 1, 2, 3, 4, 5 score. Another issue is if you are using LLM-based evaluators to train to reward LLM generation, it's gonna be biased, so it's gonna create some unintended consequences where it just reinforces whatever the LLM is generating, not actually training it. Now let's look at the method, the G-EVAL. So first we have prompt for natural language generation evaluation. So for example, you will be given one summary written for a news article. Your task is to rate the summary on one metric. Follow instructions carefully and look at the summary. This prompt should also contain evaluation criteria. So for example, you can say, we are evaluating coherence, conciseness, and grammar. So this is their example. They just append this onto this prompt. So coherence 1 to 5, you are evaluating coherence of all sentences. The summary should not be just a heap of related information, but should build from sentence to a coherent body of information about a topic, so you can explain however you want. They did it in this specific way. Now let's look at the step 2 and 3 of the chain of thought. Read the summary and compare it to the news article. Check if the summary covers the main topic and the key points of the news article, and if it presents them in a clear and logical order. Assign a score for coherence on a scale of 1 to 5, where 1 is the lowest and 5 is the highest based on the evaluation criteria. So you will be adding this manually into your code, into the G-EVALs, but you can use another LLM like ChatGPT to generate this. Of course, you can also code an automatic LLM call to generate these in your Python script. However, I think it's better if you generate it and then review and improve first manually. So this is what they do next. So let's say we are evaluating the summary of an article. Now, what I recommend, and they didn't mention this here, but when you have a long text goes at the top. And then, so article goes at the top, and then you have summary, it's a bit shorter, and then the prompt here and the evaluation criteria you just append below, so everything is one blob of text. and below that you do the chain of thought. And then at the end, they say for each of these steps in chain of thought, there are 3, you create a score 1 to 5. So until this point, we're going to have 2 issues mainly. The first issue is when you are having a distribution of score 1 to 5, for example, one number is going to dominate, for example 3 in this case, and there will be low variance, so a lot of the scores will be like 3 or around 3. And also LLMs usually output integer scores even if you tell them to output continuous scores. So this might be due to tokenization or something, but this means that subtle differences between like different cases are not captured, so both of them would get score 3 as opposed to one getting 3.1, the other getting 3.4. Now guys, I'm a little bit mad because of one thing. So the idea is good and simple, but they articulated and explained it so poorly that it took me 40 minutes to understand what they even mean. Because here they say like we propose using the LLM probabilities of output tokens from LLM. So this is very confusing, like which probabilities? Is it chain of thought probabilities? So for each token, they somehow take probabilities, they sum them here, but then this is weird because that's not what they're doing here. So it's very confusing. So now I think I understand it. So when they are generating the score, let's say number 4 is the score, they just take probability of that number 4, of that token. In case of GPT 3.5, or in case of GPT-4, because it doesn't return probabilities, they generate score, for example, 20 times. And then here, n20, and then calculate probability of each of the scores, how many times it appears. So here, for example, if they just said, instead of we propose using the probabilities of output tokens from LLMs, they just say we propose using generation probability of the score token of the number. It would be so much simpler to understand. And so a little bit of a critique again. So here they have this S, which is going to be scores, for example, from 1 to 5. So S1 will be 1, then 2, 3, 4, 5. Now they take probability of each of these scores. Now I thought there is only one score generated. So how do they have probabilities of each score if LLM generates only one score for this criteria? So now let's say we have probability for each score. We're gonna see later how they get this, I don't know yet. So what they do is they just measure probability of the score times score and then sum up all of them. And that's the final score. So it's gonna be a weighted sum, so the weighted score. And I understand that in case of GPT-4, they just try, for example, 20 generations, and then they get a bunch of different scores, and then they measure like how often each score appears. So that's how they get probabilities for each score. Now for GPT 3.5, where they are using token generation probability, it's not clear to me because I thought they are just generating it once, so they're gonna have one score and one probability. Not sure like how they get the other ones. But I think this is not so relevant because we already are not gonna use like 3.5, so we're gonna use 4 or 4.0. So we would be using this method of generating multiple scores and then counting how many times each appeared to assign probability. So for our understanding, applying this is enough. So when I say multiple scores, I mean like score multiple times, run this multiple times. Each time you generate one score. Here is the diagram, the same thing. We have task introduction, you will be given summary, blah, 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 evaluation criteria, coherence 1 to 5, and then evaluation steps. So for each step, it will generate a score. And so we're gonna put all of this into the prompt, and in the prompt there will also be the article and summary, and they are putting it at the top I think so. That's good. And then here, so for each score you get 1, 2, 3, 4, 5. You also get probability of that score appearing, and then you just create a weighted sum by the formula. You get a continuous score. Now I think they are only telling the LLM to output the score. So I think they don't see here like telling the LLM to reason about score before outputting the score, which I would definitely suggest. So then I guess the intuition behind the G-Eval is to tell the AI to score it like 20 times and then finding the average. They have a lot of benchmarks here, but now that I'm reading this paper, unless I'm wrong, I don't recommend using like this method of LLM outputting a number as a score, because at the end of the day it's still semi-random number that LLM just outputs. So instead of outputting a number, what I recommend is you tell the LLM to a more specific task for that context. For example, if LLM is tasked with checking if the email is friendly, do not tell it to output a number of friendliness. It's gonna be some random or semi-random number. Instead, just tell it email is friendly if this, email is not friendly if this, or you can just say reason step by step while about friendliness of this email, find all of the words and concepts that might not be friendly, find all of the words that might, and then assign a final verdict if the email is friendly or not. This works a lot better in my experience than telling the AI to output some score. Now let's look at the question if LLMs are biased towards grading LLM generated content higher. Let's first understand what we are looking at. So let's not look at the graph, let's just look at this line. So here in this case, human judges say that human summary is better. Here humans say that LLM summary is better, and here they say that they are equally good. However, LLM Evaluator disagrees. LLM Evaluator says that here, when they are equally good according to humans, AI summary is better than human summary according to LLM, according to G-Evals. And here, where LLM is better according to humans, G-Eval says that LLM is a lot better than human summary. And here, where humans say that human summary is better, LLMs say that still AI summary is better than humans. So we see a bias. One reason for this bias is that the quality, the criteria for quality could be same when LLM is generating and when LLM is evaluating, so they match. So whatever LLM thinks is a good quality while it's generating, it can also think it's good quality while it's evaluating, so the same criteria. So I'm gonna give you a bit different conclusion than they have here. The conclusion is don't use scores to evaluate LLMs. I found that it's a lot better if you just let it reason, because when you are trying to condense all of this information into like some scale of numbers, it's not gonna work. So if you are evaluating LLM text, you should, if you know what you're gonna be evaluating, for example, you're gonna be evaluating if summary is written in a friendly manner or professional manner, then you can say, check if this is written in a professional manner. Are there any example sentences where it's semi-professional or unprofessional? How are you going to deal with this? How are you going to rephrase it? So just give instructions like that and then, for example, if you do the analysis, for example, say, do the analysis of the professional tone. And then in the end, you can say, now you have reasoning. In the reasoning step, combine all of your analysis, examples, ambiguities, and then reason how to improve it and reason about the final conclusion. And after you have reasoning step, then you can tell it final output, and the final output is gonna be the improved version of the text. So that's how you can do evaluations. But, or if you just want evaluation to be like professional or not professional, then you can say after the reasoning, or in the reasoning, you can say, based on the analysis above, reason if this text is professional or not professional, and output professional or not professional in the final output, and then below the reasoning you're gonna have final output, and then it's gonna be either professional or unprofessional, and it's all gonna be generated by AI, like this big blob of text with everything.